Okay. So this is MN7A, vertical stretches and shrinks, and then horizontal stretches and shrinks will be 7B. So this is taller or shorter. So usually I show you in person, okay, but I can't show you in person because, well, I probably could show you in person. Yeah, I can't really show you in person. Okay, so imagine me, that's me. Okay, I'm not a very good artist. Okay, so this is me. You can put me, that could be you or me, whatever, just put me. Okay, so that's you or me. Now, if you got taller, if I got taller, say by double, okay, so I got taller, my arms and legs stayed the same. This is kind of cool with stick figures. Okay, so do you see how your arms and your legs stayed the same? Your head stayed the same, you just got taller. Okay, now if you got shorter, head stays the same, arms stay the same length, legs stay the same length. Now, doesn't taller, this is taller, doesn't the taller kind of look skinnier? Do you see the taller kind of looks skinnier? But really, I didn't get skinnier. I just got taller. Okay, so let me show you another one. Okay, these are vertical stretches and shrinks. And then I'll show you how this applies to math. Okay, vertical stretches and shrinks. Okay, now this is me again. So draw this one again. I guess we should draw a belly. This is a belly. Okay, that's a belly. It's a really bad belly, you guys. My artistry is not that good, okay? So imagine a person. You can imagine me. Okay, so this is me. Now, what if I got wider? Okay, so here's my belly. Now, what if I got wider? Okay, so my head is going to get wider too. Okay, wider. My arms are going to be wider. My belly is going to be wider. And my legs are going to be wider. Wider. Okay, I'll show you with the graph too, but it's actually easier with. So imagine a person got wider. Now they didn't get shorter, but sometimes shorter looks better. Okay, now what would skinnier look like? This is it's narrower, but we could call it skinnier. Skinnier. Okay, skinnier. So skinnier would be like my head's like a little oval. My arms are like this. Now I'm still the same height though. So my arms should still be at the same height. Usually I show you in a picture, like a physical body, but then you don't draw it in your notes because you're just looking at me describing it with my body. So, okay, so there's the head. Here's the arms are in the same position, but they're littler. Okay, they're less wide here. And then this is skinnier. Okay, so that's skinnier or sometimes called narrower. Probably one of the hardest things in algebra 2 is, and math in general, is vertical stretches, shrinks, and horizontal stretches and shrinks. So people get confused. Okay, so this is a horizontal, just so I can show you the comparison. So this is a horizontal stretch and shrink. Okay, so let me write equations for you. Okay, so let me write these in red so you can see them. Okay, so shorter, well, we'll call this absolute value, okay? So there's absolute value. That's me. Taller, okay, taller is going to be like 2 absolute value of x. And shorter is like 1/2 absolute value of x. So fractions make it shorter. Okay, so skinnier is actually opposite. So you actually would put the 2x on the inside, because remember, horizontals left and right are opposite. But we'll learn this tomorrow, not tomorrow, Monday. Okay, because that's a little confusing. And then this one's actually 1/2 on the inside. And then this is a plain absolute value of x. So we're going to today only deal with vertical stretches and shrinks. And they kind of make sense. If you have a big number on the outside, it gets taller. And if you have a fraction on the outside, it gets shorter. The horizontal ones are weird because they're opposite. So actually sticking a 2 in the middle makes you skinnier. And putting a 1/2 in the inside makes you wider. So we're going to just focus on the verticals today. Okay, so I want to show you on Desmos something. You don't have to go to Desmos. So I'm just going to demonstrate this taller, shorter as it applies to a graph. It's called a sine graph. Okay, so I'm going to change pages right now so you can see it. So take a picture if you haven't drawn all my little things. Okay, and then the homework tonight, you're going to do some problems that are by hand, not with Desmos anyway. And I just want you to see the vertical stretches and shrinks when you do it, and I'll show you how it works. Okay, so we'll have like a half homework tonight. Okay, and I know some of you guys need to catch up on your old books. Okay, so let me show you on Desmos. You won't have to go to Desmos though. You can't go to Desmos. I mean, you can go to Desmos, but you won't have all the work that we need. I just want to demonstrate for you guys something. It's kind of cool. But I think it works better on Desmos than it works on my other graphing calculator. So let's do it with a sine curve. Okay, so we're going to do functions sine. So this is one we're going to learn at the end of the year. Okay, so look at this squiggly line. Okay, this is a sine graph. Okay, now at this moment, do you feel like, what height do you feel like it is? How tall is it? How tall is my sine graph at the moment? Yeah, 1. Okay, so watch what happens if I put a number, I'm going to put 3 on the outside of the sine equation. Okay, so on the outside of the sine equation. Okay, so look at the blue one compared to the red one. Do you feel like the blue one compared to the red one is taller, shorter, wider, or narrower? The blue one compared to the red one. Okay, so do you see kind of my taller idea? Now, you don't learn sine graphs until second semester, but they work really well with the taller. With parabolas, it's hard to tell if it's taller or narrower. So do you see how that's taller? Okay. Now, if I put a fraction in the front instead, so 1/2, I just take the divided by. So if I put a 1/2 in the front instead, look what happened to my green graph. How's my green graph compared to my red graph? It looks wider, but it's not wider. But it looks wider, so that's what gets confusing on these. Okay, and that's what I want to show you. Okay, so look at the 0. Here, let me take a picture so I could show you. Look at this spot right here. Do you see these 2 spots? They're the same. So it didn't move side to side. It only moved up and down. So it is taller, shorter, exactly, shorter, shorter. Now, shorter is going to be called a vertical shrink. You vertically shrink. Okay, and then the blue one's going to be called a vertical stretch. Okay, so taller is going to be called something else later, but for right now, let's just call it taller and shorter. And later on, we'll give the official mathematics. So we'll just call it taller and shorter. Okay, so let me show you about the horizontals. Oops. Let me show you about the horizontals. Okay, so we're just looking, and then I'll make sure that you know how to do your homework for tonight. So don't worry. I'll make sure that we know how to do that before 9:25. Okay, so if I want to make it, it's funny because if you think of putting the number like 2 in the middle, okay, if you put a number 2 in the middle, it feels like if it's going side to side, it has to go left and right because it's on the inside. Okay, but if I put a 2 in the middle, it feels like 2 makes things bigger. But it's this weird, curious thing. Oh, wait. Let me erase that one for the moment. Okay, so the red one's actually behind it. So here, let me show you the red one. So there's the red one. Okay, and then this one, if you put a 2 in the inside, it actually makes it narrower. Now look at the heights. Look at the heights. The heights are the same, right? The purple one and the red one. Aren't their tallness the same? Their tallness is the same, but it got squeezed. It got squeezed left and right. Can you see that from the picture? So this is actually called a horizontal shrink. It got skinnier. Okay, so what would a 1/2 do then in the middle? So 1/2 in the middle would make it wider. But we're going to talk about that on Monday. So right now we're going to talk about just taller, shorter. Taller, shorter is real friendly. So taller, shorter is about outside. So what if I put a 7 outside? Does it get taller or shorter if I put a 7 outside? Right? So it did get taller. Okay. And then how could I make it shorter? Yes, a fraction. So 1, say 4th. That made it real short. 1/2. A decimal. 0.6. Does that make sense? Kind of interesting. Okay, now what's interesting is if you put like a 3, what it does is it changes all your dots to be multiplied by 3. So like this dot right here in the middle, let me take a picture. So this dot right here in the middle, and we do need to take notes so you have some stuff in your notebook, but right here, right now it's 1. So this dot was at 1. And then you multiply that y value by 3 and then you got 3. And then this was like 0 and I multiplied its y value by 0. Okay, let me show you how it works with absolute values. Oops, that's a picture. So let me do it with an absolute value. Where in the world is absolute values for n decimals? Okay, so let's see. X. Okay, here we go. So look at this absolute value. Okay, and we're going to focus on the dots. Okay, so our basic equation has dots right here, 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 and here, right? Those are our 5 dots from what you did last night. So if I put a 2 in the front, what happens is those y values only, not the x values, but the actual dots get taller. Okay, so let me change colors, and then we'll write this in your notes. Right now, you're not writing anything in your notes because I'm going too fast. So I just want you to see it first, and then we'll do it in the notes. Maybe that's a bad color. Let's do purple. No, oh no, purple's already that color. Black. Okay, so we're gonna do black. Okay, so what y value does this one have right now? The one I just put. What y value does that one have right now? That's 1 high, right? So we're just looking at its height. So its height is 1. So when I put a 3 on the outside, instead of being 1, it's going to multiply it by 3. So it's going to go up here. And you don't have to draw this yet. You're just looking. Let me change that back to red. Okay, we'll take notes on this in just a minute. I mean, notes where you're going to write it down. Okay, and then what about this one right here's y value? Hold on. This one's y value right here. Let me circle it. That one's y value. What one's that one's y value? 2. So what's 2 times 3? 6. Okay, so that one's height is going to be up here at 6. Now, how about this one right here? What is it? Its y value. Yeah, so what's its new y value? It's going to be 0 again. It's like your feet. Taller your feet stay in the same spot. This is like your feet. Okay, and what about this one? -1, 1. What's its new height? So what's its new height? I was trying to put a 3 in the front. So what's its new height? What are we timesing it by? You're getting 3 times as tall. So 1 is its old height, and what would its new height be? Yeah, so then that would be 3. And then what about -2, 2? What's this one's height? 3. So then what would, no, what one's that one's height? Sorry, I was looking at your answers from the previous question. What's that one's height? So what's its new height going to be? And then that's going to look skinnier. Okay, now I want to show you, but now we're going to do it in the notes. So you could write it in the notes. Okay, but then let's check. So you don't have to write any of this down yet. Okay, so let's check. So what if I put a 3 in the front of the absolute value? Did that make it the way we thought it was going to be? But you see, Desmos doesn't have the dots. So it's not going to help us as much. So we're going to take the dots and then multiply the dots by 3, the y values of the dots, the heights by 3. Okay, so that is what it looks like. Okay, so let's go back so we can actually figure out what you're going to write down in your notes. Okay, so for example 1. Okay, so the first thing I'm going to do in the first set of examples is I'm just going to ask you to identify and not graph. Okay, so what I want you to put is you're going to put taller or shorter. Okay, and then you're going to write vertical stretch or vertical shrink. Okay, so you're going to only label. So you won't have to go into Desmos for this. Okay, you're just going to have to look at the number in the front. So let me show you. So we'll call this A. So y equals, let's say, square root of x, which you don't know what it looks like. What if I put a 2 on the outside? Okay, so this is an outside times 2. So is that going to get taller or shorter? Okay, taller. So you're going to write taller for me. And then why don't we also put equals vertical? Now, would that be a stretch or a shrink? Do you feel like you vertically stretched or you vertically shrunk? Do you feel like that's a vertical stretch? Yeah, that's a vertical stretch. And that's the official math word. So instead of making you graph, I'm thinking that maybe I'll have mostly that you just label. So you can get used to the vocabulary. Okay, and then maybe I'll have you graph like 2. So you can see it in action. Okay, okay, B. What if you have y equals sine x and you have y equals a third sine x? Now, and you don't have to type these into Desmos. You could if you wanted to see them, but it's hard to tell wider or taller. And we're only doing verticals. Okay, so these are our only choices. So horizontals are going to wait for another day. Okay, so for this one, just put outside fraction. We'll call it an outside fraction. So outside is always up and down. Okay, so outside's always up and down. So would that be, so it's taller or shorter? Outsides are always taller or shorter. So is this one a taller or a shorter? So this one's a shorter, so you're going to write shorter. And then what's a shorter's official name? What's its official math name? Vertical shrink, exactly. Vertical shrink. Okay, so C, we're not going to have any insides. Everything's going to be an outside. What if we have 0.6 absolute value? Oops, sorry, I got to write the main equation. I got to write the basic first. So you got to write the basic first. And then this one is 0.6 absolute value of X. Okay, so this one is a fraction, right? I mean, I know it's not a fraction. Zero point blank. Now, if it's 1.6, that's going to still be a stretch. Okay, but 0 point something would be a what? So what's the official word like for our brains? Because vertical shrink and vertical stretch don't mean anything to your brains at this point. So I agree, it's a vertical shrink, but what's its other word? What's its like word that makes more sense to us? Yeah, shorter. Okay, so shorter. So I'm going to have you write shorter and then vertical shrink. Sounds good? Okay, any questions on this so far? Your answers are only going to be taller, shorter, vertical stretch, or shrink, and that's it. Okay, and then you're going to have, then I'm going to have you graph 2 of them to see a vertical stretch in action. Okay, so I'm going to have you see a vertical stretch in action by hand, not with Desmos, but I'm just going to have you graph 2. Now, this is new from last year. Last year, I have this worksheet that I like, but it doesn't help students as much as I wish helped students. So I'll make a worksheet that helps here, and then we'll really get it straight. Because these are always confusing to my students. So I need a better way to explain it. So this, I think, will help you today. Okay, so it's kind of good that we're on a Friday where I don't have time to teach both horizontals and verticals, because then you'll keep them separate in your brain. Okay, so example 2 is I want you to graph y equals absolute value of X and y equals 3 absolute value of X. Okay, by hand. And then I want you to label the effect. Okay, so label the effect is going to be taller, shorter, and vertical. And you're going to want to write the whole word vertical out. Like, don't abbreviate, because you want to get used to the terms, vertical shrink. Okay, so you're going to graph and label. Now, what do we expect to happen? What do you expect this to be? Taller or shorter? Okay, so we just want to see it in action. Okay, so we're going to make 2 XY tables. Okay, so you're going to make 2 XY tables and substitute numbers in. Okay, so we're going to substitute our main numbers in. And this is just to get familiar with the actions. So when I substitute these numbers in, what are my 5 answers? Can you just tell me all 5 of my answers? So we could do it all together. What are all 5 of my answers? Liana, you're good, but you're doing for the x squared one. So Liana, your answers are right, but those are for x squared. Okay, so these are the numbers. Now these numbers, when I substitute them in, I get 3 absolute value of -2, 3 absolute value of -1, 3, 0, 3 times 1, and then 3 times 2. So I'm going to put this in my head, a little bubble. So what do these answers turn out to be? So what do you think? What do these 5 answers turn out to be? Yeah, and those are the ones we actually did in the Desmos one, right? Where I was saying, how does it get 3 times as tall? So the y values actually get to be 3 times as tall because there's a 3 times it in the front. So now you need to graph so that you can get up to 6. So you need a spot that you can get to 6 high. Okay, so you're going to graph both. Oops, wow. Okay, so we're going to get one where we can go 6 high. Okay, so we're going to graph in one color, your normal absolute value graph. Draw dashed. That's going to be your basic. And then this -2, instead of going up to 2, it goes up to 6. So you don't have to do it. I want you to see the effect. You don't have to use the taller multiplied by 3 that we were doing in the notes. You just graph those points. So I'm just graphing these points. Oops, that's in the wrong spot. Okay, so graph this point, graph this point, graph this point, graph this point. Okay, and I do need you to put the dots. See, Desmos doesn't put the dots, so you can't tell whether it's wider or taller. Skinnier, narrower. Okay, but we're not doing skinnier today. So we're only doing taller, shorter, vertical stretch, vertical shrink. So what do you think? What does your graph look like? Does it look taller? Does it look shorter? Okay, so it looks taller. So you're going to write taller, and then a taller is a stretch or a shrink. Okay, so stretch. So you're going to put vertical stretch, and you're going to put taller. You do have to put the word vertical because later on there's going to be horizontals. Okay, now for y equals x squared, you're going to use the other numbers, right? Well, I won't say use. Put has a different, right? Doesn't it have a different thing right there? Okay. Okay, so I'm concerned with 5 minutes between classes, so I don't want to keep you over because I don't want you to be late to your next class. Okay, so I will make you a worksheet, but you guys, it's gonna, I don't have any time in between classes. So I need to write you this worksheet, so it's not gonna be posted exactly at, I'll try to post it by 1. Let's see how fast I can make your worksheet, okay? Okay, so you guys, you can say goodbye. Thank you for coming, you guys. It's been really great these 2 weeks. I'm so glad to have you. It's a little stressful distance learning, but you guys are awesome. You guys really are awesome. You too.